Okay, hello fellows. Welcome, and today I'm going to be demonstrating you the Linux version of monitoring your DragonBoard that we were actually taught in the Internet of Things sensing and actuating from devices. Basically, the server which we wrote on there was written in Android, and basically I am more hands-on with the Linux environment in the Python programming language. So this is especially for those who are more used to in the Linux environment like me. So for those who have not taken the course Internet of Things Sensing and Actuating from Devices, still this video will be helpful to you guys because we are going to develop an HTTP server that will be capable of handling multiple clients and the techniques which we'll be developing to communicate between the server and the clients. Specifically, we'll be developing AJAX technique, that's asynchronous JavaScript and XML. And apart from that, we will also be looking at how you can parse JSON data between the client and the server. So before diving into the code, I just want to tell you that what will be the outcome of this server, that basically what this server will be doing. So basically my DragonBoard has GPS, Wi-Fi, and Bluetooth, and some of the GPIOs. So what we'll be doing is we will be fetching the information from the DragonBoard. For example, its processing speed, its memory usage, and the GPIO status, and the Wi-Fi, Bluetooth, and the GPS. So once we have got all of the information, and then we're going to be storing these information into memory, and that memory will be in the form of JSON data, and that JSON data will be actually sent to the client so that client can view all of the data in real time. We'll also be controlling the actuators. In our case, these actuators will be three LEDs, red, green, and yellow. So let's start off with the code, and be with me, and I hope you will enjoy. So, okay. So these are some major important libraries that we'll be using for our code. So I'm using Flask micro framework server. It's a very popular framework server that is being used by a lot of developers. So in this video, I will not be explaining you how to use Flask, but I have set it up a very basic Flask server with the help of which we're going to be monitoring our DragonBoard. So yes, I have imported some Flask libraries. I have imported the JSON time psutil. This is the library to get the information of the system, basically the CPU usage, the memory, and blah blah. So threading and all of the user informations. Okay, so I've created an object of the GPIO, GP, and similarly the object for the Flask as app. So these are my IP and my port, and okay, so these lock objects I have created for three individual. Okay, I have my dictionary that is the whole JSON format of my information that will be exchanged between the client and the server. So this is the same exact JSON format that we used in the Android part. It's written exactly the same: status, computation, course, then networks, then GPIOs informations, and then peripherals, then last update time. So basically, when we start the code, we are actually running a thread, and it targets the function called processes. So in our processes, we are actually updating few of the parts of my dictionary, and those are the number of cores we will get from this library, number CPUs. So it will return me 4 because I have 4 cores. So and then we have the CPU usage. Okay, CPU raw is equal to PSUTR, and we are calculating the percentage, and we are updating it in the my dictionary networks computation CPU usage as how much CPU usage it is. And then we are getting the virtual memory as well and updating it into the memory usage. So this process will be running in parallel alongside with the server, so that we can get the current CPU usage and the memory. So, and after that we are actually running our Flask application, where our server will actually be running. Okay, so application is running in the IP address of my IP. I've assigned it above, and right now it's just at localhost. So threaded equals true means that this Flask application will be running in a threaded form. Basically, it will be running in parallel alongside with my other processes that I am running. For example, this will be running independently, and my Flask application will be running independently. So debug equal false, and port is my port. So currently it's 80. Okay. So okay, so let me show you my redirecting routes. Okay, so this is my folder where my server is actually placed. So in the templates, it actually finds the HTML pages that needs to be accessed. So first of all, I have two pages. One is hello and one is live. So in this hello, if I open this, so I am actually getting this page. Hello, welcome to the DragonBoard410c monitor server. So we have 4 to 5 redirecting routes. So number one is \status. So \status, then status pretty, then status live, and then we have the LED controls. So all of these redirecting routes are being handled in my Flask application. So if I look at my application, okay, so these are my redirecting routes. So the number first one is if I get nothing but backslash, that means I'm accessing the page right now. I mean, if I write the IP and press enter, I will get the request of backslash get HTTP 1.1. So it actually takes that request, and in response it actually gives in return the template that is hello.html. So of course, first of all, it checks the arguments as well, the arguments of the list. If I get the arguments of led, and then further it will gonna process the whole the led process. But right now I'm just getting the I'm just accessing the page, so it will just return me the hello.html page. So, and then we have status, backslash status. So if I write my IP address backslash status, so it is going to update my dictionary. Last update equals time, the current time, and it is going to return the whole JSON formatted structure in my web page. So that's, yeah. And then if I want the status in a prettier manner, so I will write status backslash pretty. So then again it updates the time and returns me my dictionary in JSONify method. So basically it's just a function of the Flask, that if you want it uh, in a JSON manner, so you can actually use this. So, and we have status.live, in which we are actually returning as a response to the client live.html. Okay, so once we have opened the page, so at the start it is not going to go inside this if. It is just go to this else and give me the hello.html page. Okay, so now what if I want to control the LEDs? So this it's the same format is used as we used in an Android version. So if I write like um, 1 and 2.168.1.2, let's say it's the IP of my DragonBoard, and if I write question mark LED equals red and time equals 10. So this is actually the whole string that we are getting. So it first checks the argument that have you got LED or not. So yeah, we have got LED. So then we are going to check that if we have got times or not. Okay, so if argus.get times, Okay, if you got times, then go to this if. So if we have not got the time, so else this is going to run a separate function, that is led.control. We are passing two arguments. One is the led, so led is red, and this is the times, that how many times we need to turn on this led. So by default it's 1. Like if we not got any time, so the default time will be 1. And okay, this function runs and it is going to return some of the things. Okay, let's have a look at this function. Led control takes led and time. Okay, so if led equals red, then just convert the time into integer form, and start the separate thread in which red led is going to blink. So here I'm starting the thread, threading the thread, target is equal to red led, args equals time. So I'm just passing the time, that how many times the led needs to be blinked. Okay, so red led. So here is my function. I'm calling this function as a separate thread. So passing the argument times, and importing the GPIO library and assessing it as output. Okay, so now here I am acquiring the lock for of the red led. So acquired the lock, doing the process, and finally releasing the lock and closing the pin as well, of course. So simple for loop in which it's blinking the led for n times. If the time was 10, then the for loop will run 10 times. So it's also displaying how many times the red led is glowing. So, and also it's updating my dictionary function status GPIO to values, and it is getting the values of this GPIO and updating it into the dictionary. So finally we are releasing the lock. Okay, so I have created three objects of the locks because we have three GPIOs. That means we are actually controlling three of our actuators. So we need to know that which actuator is busy right now, or which is vacant, or which is available to use. So for that purpose, I have three separate objects of the locks that I have defined over here. Threading lock, that is red led thread lock, yellow led thread lock, and green led thread lock. Okay, so where it is, yeah, over here. So I'm checking that if the red led thread lock is locked or not. Basically over here, when we are inside this for loop, uh, the lock value of that lock object of this lock object will be true. Okay, so that means that this led is being already in use. So I have acquired the lock over here, and it is being acquired while this processing is being done. So currently the lock will be true. So over here, if red led thread lock dot locked equals true, that means this else, then it will gonna return me red led already in use. So this will be equal to false when the whole process in this for loop will be done, and it will go to finally statement, and after this statement I will get my lock released. So this lock will be false, then only then I can start the thread again and it will return me okay. So that's the whole concept of the locking and acquiring the threads, and the best approach for using the threads. And similarly it goes for the yellow led and the green led, and similarly for all as well. So starting all of the threads and checking whether all of the threads are false or not. So if they are true, then all leds are already in use. Okay, so okay, let's comment this. Okay, and one last thing, when we actually start the code actually uses the library of the Wi-Fi and it checks that whether the Wi-Fi network is connected or not. So this is the function that I'm using. If I'm connected to the network, it is going to return me this list, and inside this list it will be written cell SSID equals your SSID. So I'm storing it inside SSID and converting it into a string, then extracting a substring from that string from index 10 to the index of this backslash, oh sorry, closing bracket. That is going to return me MAXCOTEC, the exact SSID name that I need. So once I got the SSID name, just updating it into my dictionary. SSID is SSID, status is equals connected. Else, if I get the length of the list not greater than 0, then that means I'm not connected, and just display this and not connected into the network's Wi-Fi status. Okay. So one of the additional features that I have added in this server is you can actually view the live streaming of your DragonBoard. So basically I have created a simple HTML page that is named as live.html. Okay, so if I open my live.html, so it is going to be like this: my DragonBoard competition, number of cores, and all of the information is shown in an HTML format in this way. So networks, Bluetooth, locations. I've displayed the GPIOs in a table format. So here the values will be displayed whatever the values of the GPIOs are coming from the server. So over here the peripherals, the USB devices, and the last update information. So if you look at the code of this index live.html, it's a simple HTML code written. So some JavaScript functions that I'm using over here is like when the body starts, onload equals keep alive function. So this function is actually started when I open the page. So what is actually happening in this function is, so it's actually requesting requesting something from the server, and server is responding back. So what is actually being requested that is sent is function keep live. So I'm making a variable request, and it's of type XML HTTP request, and then okay, so I'm creating a post request that will be sent to the server. And what is that request? In that request it's written update status, and actually this is actually I've made a post request, and I'm simply sending the request to the server. Send null. So the server is going to receive this update status post request and respond JSON the whole JSON string back to the client. So this process, the keep alive function, is actually getting timeout after 200 milliseconds. So what actually happening is after every 200 milliseconds, my client is sending a post request to the server of update status, and the server is actually responding to that post request the whole JSON the whole JSON format, and in which all of the status is actually being written. Okay, so once I have sent the request, the server will receive the request over here. Okay, so once okay, so here I am sending the live.html, and once the live.html is opened, then I will receive the request from the client as status backslash update status. So this request will be given to the server after every 200 milliseconds. So it is actually responding to this request and giving the whole JSON dictionary to the client in to the client. So the client is actually receiving the whole information of the dictionary, and over here I am doing the JavaScript magic to just convert that whole response from the server to JavaScript to JSON, and storing it in JSON object. So further, I am accessing all of the data from the JSON object and writing it to my HTML page. So for example, the ID for my course was course ID, and I am actually writing in this course ID what actually I am getting in competitions.course. So this is how actually you extract the data from JSON in JavaScript. So course ID was like over here, number of course, span ID, course ID. So initially it's dot dot dot. Now further it will be updated with what I will get the response from the server. So for example, in here I will get 4, and similarly I have assigned all of the IDs for all the information that needs to be updated. Okay. So this is the whole information that is being updated after 200 milliseconds. Computations, core, CPU usage, memory usage, Bluetooth, blah blah, everything. So GPIO informations as well, that what's the value of 29th GPIO and what's the direction, and sort of like that. So that's the whole idea of the HTML page, that how the information is being sent to the server and being received from the server. So this feature is very cool. I'm going to demonstrate you this, and you're gonna love it.